This video is about the restoration of the DC platter motor in Beogram 4002 and 4004 turntables. I'll show how to disassemble the motor, how to get out the brass bearings, how to infuse them with oil. Then I will show how to reassemble the motor, and I will show how to do an RPM stability test with the beolover RPM device after the motor is running again. For more information, please visit my blog at beolover.blogspot.com or go to my website at www.beolover.com. Let me first discuss briefly what causes RPM fluctuations in Beogram 4002s with DC motor. This here is an example of curves that I measured with the beolover RPM device during the restoration of a Beogram 4002. The curve at the bottom here, that's the curve that I measured as the deck presented itself before I started working on it. And so these measurements, they are over 24 hours. And so you see here, there are several percent variations, drops in the RPM. And so this here is way too large, and it's impossible to enjoy a record if you have these kind of spikes. After rebuilding the motor, this curve was measured. And so you see here it got dramatically better. So this here is actually something that the casual listening will not reveal anymore. But you see here there is a drift over time. The RPM goes up a little bit, and then we still have these smaller variations. And so these smaller variations, it turned out they came from the RPM relay and the RPM trimmers. So I usually replace these here with encapsulated modern 25 turn precision trimmers. And also I developed this adapter board for a modern encapsulated relay that has a few million of switches guaranteed before it will fail again. So installation of this here already cures a lot of these smaller variations. This is this curve here, but you see there are still a few smaller spikes over time, and these spikes I believe are caused by heating up of the user accessible RPM trimmers that are above the keypad of the Beogram 4002, and I think this is caused by heat that's coming from the light bulb. And so replacing the light bulbs with LEDs, these here are boards that I developed. They plug in directly where the light bulbs are soldered in this RPM scale illumination. By replacing the light bulbs with the LEDs that run much more cool, so the trimmers aren't being heated up that much. With this, finally, we arrive at this curve, and so you see now it's very stable. We still have a little bit of an increase here at the beginning. This simply comes from the fact that the turntable is warming up slightly in the first hour, simply because the transformer gets warm, etc. And so this changes the analog control system slightly, and so the temperature increase changes the RPM a little bit. But then after that, it's very stable. So essentially, if you want a really stable RPM performance, you need to do all of these things. But this video now is focusing on alleviating the main issue, which is failing brass bearings in the DC motor. So I will show how to take these bearings out and infuse them with oil and put everything back together. If you're interested in doing this yourself, the relay, the trimmers, the RPM scale LED and the beolover RPM device are available to other enthusiasts. I also offer complete restorations of the DC motor. You can just send it to me. If you're interested in any of this, just send me an email or use the contact form on my blog. Okay, after this little sales pitch, it's time to get down to it. So let's take the motor out. Some of them have 3 screws, others have only 2. So there's only this one plug that needs to be removed, and then you take out the mounting screws, and then you can extract the motor. Here we go. The next step is to take this mounting fixture off, and here now you see the example of a motor that has only 2 mounting screws. But from here on it's all the same. So you just take out these 2 screws, and then this fixture comes off. The next step is to take the pulley off, and sometimes it just comes off, but more often than not one has to help with a screwdriver and pry it off. So once it's off, it's a good idea to check if there are glue remnants. Some of them apparently are glued on with super glue or something similar. And so typically there are glue remnants on there that make it impossible to pull the shaft through the bearing that is underneath here. And therefore, with a razor blade, all glue remnants need to be removed. Otherwise, it is possible to force the bearing out of its fixture and thereby damage things when you extract the rotor. The next step is to extract the motor from the outer shell. This outer housing here that is applied to reduce the noise of the motor. And so we just take out these two screws, and then we can get the motor. Okay, now we can finally take the motor apart. And before you take out these screws here, it's a good idea to make a marking here at the side that allows you to determine how to put the bottom plate back in when you reassemble the motor. If the bottom plate is not in the same orientation, the motor can either run in the opposite direction, which is of course not great, or it doesn't run at all. So there's only one of the three positions that actually gives you a motor that runs in the right direction, and so it's a great idea to make a marking here before you take the screws out. I forgot to do that when I made this video, but anyway, so I really recommend to use a Sharpie pen and make a little marker. So once the three screws are out, you can just push the shaft in, and so the bottom plate comes out. And it's hard to see here, unfortunately, because of the illumination, but here is the commutator, and the two brushes are on the commutator, and so when you pull this bottom plate off, the brushes are sort of ripped off the commutator. It's a little bit brutal, but usually nothing happens if you just pull this bottom plate off carefully. So here you see the two brushes, and this is the commutator. And so now you have the rotor out, and it's time to get to the bearings. One more thing, sometimes what happens is this plastic washer that separates the bearing from the rotor, that stays in here, and so it's a good idea to check for that, whether it's on the shaft or whether it's still in here, and then secure it. So in this case it remained in, and so we need to take it out, and so I just stick it back on here on the rotor so it doesn't get lost. Let's do the top bearing first. That's the easy part. So the top bearing is held in place by a ring that's underneath here that is held in place by these three tabs, and so we need to lift up two of these tabs, and then we can take the ring out and the bearing comes out. So with a small screwdriver you bend these up a little bit. Can be sometimes tricky to get the screwdriver underneath here. So you see now it's loosening up, and they need to be pretty vertical in order to get them through these slots. Okay, so let's see. So here now you see the ring. Well, I guess we need to bend them up a little bit more. Okay, now it's out. And so now here there is this spring that holds the bearing in place, so this needs to go back in the same orientation, otherwise it doesn't work. After taking out the top bearing, we need to take out the bottom bearing, and that's a little bit more involved. So the first step is to take off this printed circuit board, and for that we need to unsolder it on 3 locations. Okay, so now these 3 solder points are cleaned of solder, and so now we can pop the PCB off. So now carefully pull the PCB off. Sometimes it's a little bit stuck, but here it came off. The next step is to take out the brushes, and for that we need to remove these two screws, and then they come out. These two screws also hold that internal board to the metal enclosure. So it's essential that these screws are out. It's important to note that this tab here is connected with a very thin wire to one of those inductive coils that are used for the RPM feedback process. And so you need to be a little bit careful when working on this, because it's pretty difficult to repair this in case one of these little wires here breaks off. Okay, almost there. Our goal is to be able to lift up this internal board a little bit, so we have a crack here on the side through which we can extract the bearing, which is held in place by this spring ring. And so the last thing now that separates us from being able to do that is that these inductive coils are press fit onto these pins that are connected to the metal enclosure. And so if we want to lift up the board, we need to be able to move the coils up on these pins. And a good idea is here now to use a small screwdriver and pry up these coils a little bit, and then one is able to lift up the board. So with a small screwdriver I go underneath here, and again I need to stress the coils are connected with these very thin wires to the solder points, and if you break off one of these wires, then you'll need to do some precision soldering to get things working again. So careful now, and take a deep breath while doing this, but as long as you move the carrier together with the coils, nothing happens here. So this is sort of the dangerous moment when we only move the coils but not the PCB. Okay, so now the coils are a little bit loose. Now finally we can put a screwdriver underneath here and lift up the board a little bit, and so with this we create a crack through which the bearing can come out. You see that here? So now we have this crack, and now we can finally go in and get the bearing. So this is that spring ring, and so the bearing now sits here at the bottom. So I forgot to mention one thing, the bottom bearing. So we have both bearings out here now. The top bearing is a little bit larger than the bottom bearing if you ever get confused. And there's one more thing that I need to point out. The bottom bearing, and unfortunately that didn't come out in my video clips that I just showed, that has below it a small plastic disc that is sticking to the bottom with a little bit of grease. And so this plastic disc, that essentially takes the weight of the shaft that goes through the bearing here and reduces the friction with the metal enclosure bottom part. And so it's important that this here doesn't get lost, and that when you assemble the motor again, that it is really underneath the bearing. So look out for this here when you take out the bottom bearing. Usually it just remains stuck to the metal part, but sometimes it comes out, and so it's important to look out for it and make sure that when you assemble the motor, it's again underneath the bearing. Okay, so now it's time to infuse the bearings with fresh oil. The oil infusion of the bearings requires that a vacuum is being pulled to get the air out of the bearing pores. What I'm using here is a food saver vacuum pump that can evacuate mason jars, standard mason jars. And so I just put a little bit of SAE 30 motor oil in here, And now I'm dropping the bearings into that motor oil. And then I use the evacuation attachment for mason jars and put it on the mason jar. And now we can pull the vacuum. And so what we see here now is that as soon as the vacuum builds up, we get air bubbles coming from those bearings. You see here now they are developing. And so this here now will go on for many hours, and when it stops, then the bearings are infused with fresh oil. Okay, so while we wait until the oil goes into the bearing, why not look real quick into these oilite brass bearings? I found it interesting enough to search a little bit on the internet about them. And so what I found is this interesting picture. This is a polished slice of one of those bearings under a high resolution microscope. And so you see here these phases of the bronze copper tin alloy, and in between there are these black areas, and these are the pores that are here in this bearing. And so when we pull a vacuum, the air that is in these pores, in the system of pores throughout the metal, the air expands dramatically and thereby leaves the bearing, and that leaves behind space for the oil that can then diffuse into the bearing. It's interesting to note that when you get a freshly infused bearing, it has about 20% oil in it by weight. And so this oil now slowly diffuses out and creates a lubrication film on the bearing surface between the bearing and the shaft. And for many, many years, such a motor can run on this lubrication film, but eventually, of course, the oil will run out because the shaft, of course, always extracts a little bit of this oil and distributes it outside the bearing. And so over time, less and less oil is in here. And so after 30, 40 years, it's time to re-infuse these bearings. And so this is what we're just doing now under the vacuum. Okay, time is up, 24 hours later, and so you see here no more bubbles. And that's the moment when we can take out the bearings from the mason jar and put the motor back together. So basically now we do everything in reverse. So the first step is to get that plastic disc back in. So that needs to sit here at the bottom, right in the center. And then we can put the bearing on top. Make sure it's the smaller one, right? The bottom bearing is the smaller bearing. Okay, so on top of the plastic disc. And now it's time to put that spring ring back in. This is a little bit a test of patience, but usually it's not too difficult to get things back together. So the first step is to secure the PCB in place by pressing the coils back down on their pins. And here, of course, we need to be careful to not break those wires off. So in essence, make sure the wires are not underneath the coils when you press them down. Okay, so the worst is over. I usually check the resistance of the coils when I'm at this point to make sure that everything is still okay, and so usually I get like 17, 18 ohms across the coils. Now we can put back the brushes to make sure that they go underneath here. This is not too difficult, it just needs a little bit of patience and a steady hand. Sometimes it's difficult to get these screws back in. Just listen to some quiet music while you do that, and you'll be fine. Here we go. Brush number 1 is in. And here comes brush number 2. I had to straighten out the the brush contacts a little bit. It's important that these bolts are tightened fairly well, so that while the motor vibrates, things don't come apart. And now we can start work on the top bearing. So it just goes in here and then put the spring on top. The difficult part with the top bearing is to get this ring back in, that it sits snugly and really holds the bearing in place without letting it wiggle. So at this point the issue is that this ring is now only held in place by my finger, and the magnet inside the enclosure will pull it back out if I let go. So at this point now we need to secure it by bending the tabs a little bit so it stays in when I remove my finger. Now comes the difficult part, or at least it was difficult before I designed these 3D printed tools here. Now we need to press down these tabs that the bearing is really held in place here very tightly. And so this is virtually impossible to just by using your finger and holding it in place and then trying to bend them here, etc. One really needs to apply some force in a very directed manner. And so with these tools here, it becomes pretty easy. Right, so I just put this cylinder in there and then this ring on top that has these protrusions here that fit exactly on the tab, and then with adjustable pliers one can really apply some significant force here and clamp them down. And so I just go around here now and press one after the other. So one of them didn't look appropriate yet, so I needed to give it a little bit more. Okay, now they're really flat and the ring is not wiggling. Okay, the worst is over. Now we can put the motor back together. So in order to get the bottom end of the shaft into the lower bearing, we need to move one of these brushes out of the way with a finger, and then one can push the other brush over a little bit with the shaft end, and then try to get the brushes across this plastic ring onto the commutator. So this looks a little bit difficult, but in reality, if you just wiggle this around here a little bit, the brushes simply snap over here onto the commutator. So let's see. Unfortunately, this is a little bit blurred. So here you see I pull up the spring with my finger, and now I work the shaft into the bearing. And so at this point, of course, you need to check if the brushes are on the commutator. So the next step is now to get the upper end of the shaft into the upper bearing, and since the magnet in here will suck the rotor inside and potentially out of the lower bearing, it's good to put a finger at the other end here and then let the shaft through in a controlled manner while feeding the bottom plate in. Okay, so the motor is back together. Okay, now we can put the 3 screws back in. It's very important that these screws are tightened in an even way, otherwise the motor will not run well. So it may well be that once we test this motor that we have to open these screws again and retighten them until the motor runs well. Unfortunately, I forgot to videotape how I soldered the PCB back on, but it's simple, it only fits in one orientation, so just stick it back on and solder it in place while making sure that it's really all the way pressed down. Anyway, once it's on, it's time to test the motor. I just hook it up to my bench power supply. And so the negative pole of the bench power supply goes to the connector in the middle here. That's the blue wire here, and the white wire is connected to the positive pole, and I apply 5 volts. And so when you do it like this, then the motor should spin in a clockwise direction. If it spins in the other direction, counterclockwise, then you need to rotate the bottom plate by 120 degrees. Likewise, if it doesn't spin at all, but you get a high current, then also you need to rotate the bottom plate. So there's only one position of the 3 possible positions of the bottom plate that give you a motor that rotates in the right direction. So it's really a great idea before you take the motor apart to make a mark here to ensure that you get that bottom plate on in the right orientation. When the bottom plate is on in the correct orientation and the screws have been tightened carefully and equally, then you typically get a current that is lower than 30 milliamps. If you get a 3 here, or 4 or 5, or it can even be a 9 or a 10, then something is wrong and you immediately need to turn off the motor because there is a large current in the rotor, and of course that's not good for it. So when that happens, then it's time to open these 3 screws again and retighten them until the motor runs at 20 to 30 milliamps at 5 volts. Now that the motor is running properly, we can put it back into its noise reduction enclosure. So first comes that little rubber boot, and then it goes into the enclosure. That's completely uncritical. It only fits in one orientation, and the 2 screws can be tightened at will. Okay, that's it. Once the outer enclosure is in place, you can put the pulley back on. In many cases, it simply makes a press fit with the shaft, so you can just push it down and make sure that there's a small gap below. In some cases, the pulley fits pretty loosely. Those are the cases when you typically find the glue on the shaft after you pry it off. In those cases, you need to put some glue on here, and I use super glue gel. So I just put a dab around the top end of the shaft, and then I press the pulley down, making sure that the gap is down here, and then I let it sit for a few hours until the glue is hardened. And then we can test the motor. And so all we need to do now is bolt it back into the enclosure. I'm showing it here with the 3-hole mounting plate. There are also mounting plates that have only 2 holes, but you get the idea. So when you put in the plug here, it needs to match that the red wire is here on the back contact. And now it's time for a test run with the beolover RPM device. That's it. Now you know how to restore the DC motor in a Beogram 4002 or 4004. If you're interested in getting your motor rebuilt or would like to obtain the beolover RPM device or my assembly tool, just send me an email or use the contact form on the blog. Thanks for watching.